Today's video we will discuss about the indices of a expression. Say it is written here root x. How to differentiate that root x? If I write in front of it divide dx, how to differentiate it? So we know that root x we can express as a x to the power half. X to the power half. Just according to the rule of the indices, you can apply here half in front of the x. Then from half we needed to subtract 1. Half minus 1, so finally we got from here half x to the power half minus 1, which is minus half. So we can leave our answer here. This is the first part. So say another part, if it is written there cubic root of x, say cubic root of x inside of the root 3 is written there, we also can write it as a x to the power 1 by 3. Now it is possible to differentiate. We all know dy dx of it is x to the power 1 by 3. Then just according to the rule of the differentiation x, then 1 by 3 minus 1, subtract 1. Then we got from here 1 by 3 x to the power 1 by 3 minus 1, which is minus 2 by 3. So this is our answer from this part. If it is written here in front of the root x, say 4 root x, what is the differentiation of that? Same as like it, we can write it by 4, then multiplied with d by dx of root x, divided by root x. From the root x we got this value, we can put it here directly, which is 4 into half x to the power minus half, and finally we got from there 2 x to the power minus half. That is our answer from this part. So let's say another question, slightly difficult. Say it is written here root x, then outside of the expression it is written there 3. So according to the rule of indices, we know root x you can write x to the power half, and outside there is a 3. We know power, then another power, then you can write it as a x to the power half into 3, which is 3 by 2. 3 by 2. Now differentiate derivative of that expression, and derivative of that expression is the same thing. So while we are going to differentiate anything, we needed to write as a power of x first. So according to the previous rule, you can write it 3 by 2 x to the power 3 by 2 minus 1, which gives us 3 by 2 x to the power half. So that is our answer from here. Even any question is written there, say root x, but inside 3 is given, what the expression is, we also can write it x to the power 3, then outside is half. So after multiplied of the power another power, then it gives you x equals to 3 by 2. Now you would say with me, definitely we would get if we differentiate this one, because we already have the result of on the right side. You can write the same result if I differentiate it, which gives us 3 by 2 x to the power half. Another example from the indices, if it is written there cubic root of 3, then inside it is written here x to the power 5, then accordingly you can write x to the power 5 by 3 again, because inside of cubic root of 3 it gives us 1 by 3. Now differentiation of that, actually we needed to differentiation of that expression d by dx of same thing. So now differentiate according to the rule of differentiation 5 by 3, then from the power 5 by 3 minus 1, it gives us 5 by 3, and then x to the power 5 by 3 minus 1, it gives us 2 by 3. So that is our answer. Another example, if written with the expression with the division sign, say cubic root of x plus 3 root of x, then on the below it is written there, say x to the power root x. So first what we needed to do, just write the expression as simple as possible as a single term of x, single power of x, then we can differentiate it. We also can apply here the quotient rule. Better not to do this here because it is possible to write in a simple expression. Say we can write it x to the power 1 by 3, then x to the power half below, because we know that root x is x to the power half, then plus 3 by root x, 3 by x to the power half, then x to the power half is below. So the expression becomes x to the power 1 by 3 minus half. Then the second part is from here we can cut out x and x, 3 is remaining. So finally we got from here x to the power 3 by 2 1 by 3 minus half, which is minus 1 by 6 plus 3. So differentiation of that one, we can move directly to here. Differentiation of that one, I think it's now easier for you. d by dx of x to the power minus 1 by 6 plus 3. So we know that minus 1 by 6 as a power, we need to write minus 1 by 6 x to the power. Then again from the power we are subtracting 1, and 3 is a constant, so it gives us 0. So finally we got from there minus 1 by 6 x to the power minus, just add this to value, minus 1 by 6 minus 1, which gives you minus 7 by 6. So we can leave our answer here. Sign, say root x, and inside something written there 5 x square minus 3 x to the power minus 1 plus 7. Just remove the bracket from here. It gives us 5, according to the rule of indices, 2 plus half we needed to write, because if I multiply with the half and this one, we are going to add the power. The next term is minus 3 x to the power minus 1 plus half, and the last one we would get from here 7 x to the power half. We needed to write everything as a power of x. So 5 x to the power 2 plus half, which is 5 by 2. Then next one minus 3 x to the power minus 1 plus half, which gives up minus half. Then last term is 7 x to the power half. So now the similar rule we can apply here. If the plus minus sign, you can split it. So differentiation of that one, we needed to move directly to here, which is d by dx of here. Now from there we'll get from there, say 5 into 5 by 2. Then from x power we need to subtract 1. Then another term minus 3 into minus half x to the power minus half minus 1, and the last one as well 7 into half, then x to the power, this is the question, another question, x to the power half minus 1. So finally we would get from here, say 5 5 is the 25 divided by 2, and power of x as a x to the power 5 by 2 minus 1, which is 3 by 2. Then minus this 2 minus sign makes it plus 3 by 2, and power of x becomes minus x, sorry, x to the power minus 3 by 2, and the last term we can write it 7 by 2, and add the power x to the power half minus 1, which gives us minus half. So we can leave our answer here. That is the total thing of our today's class. Next class we will discuss the questions like this. If the expression is written as a y equals to something, or fx equals to the expression is given, uh, we will get from there dy by dx, which is called the gradient expression of the curve. And fx, we can write here the same working f prime x, which is called the derivative of fx. And the cool thing is, before like before, I have one indices worksheet for you, which is given the questions like this: the formula first, then some indices rules are there, then for your practice some questions are there, 1 2 3 4 5, all the questions are here. The cool thing is that will be given in the description, so you can download it for your practicing. From the description, that PDF file has been uploaded, so you can download from there. Thanks for watching. You're welcome to see the next video as well.